All right, so we're going to finish the notes from Thursday on Monday. So skip a couple pages. I would skip at least 2 full pages. If you write bigger, maybe skip 3 full pages before turning to a clean set of pages. And this is going to be page 17 on the left. So again, we didn't quite finish the lesson, so skip 2 or 3 full pages to give yourself room to do that lesson before you write this down. But skip a few pages, and then page 17 on the left, this is a review. Write the equation of a line through the points -1, 3 and +3, +4. Give the answer in both standard and slope-intercept form. Now we haven't learned how to do this yet. We will go over this on Monday, but just have it written down in that space so you have it ready to go. And you can pause the video at any time if you need more time to write something down, or you can go back and watch it again. So just get that written down, give yourself some space to work it out. Then on the bottom half of that page, the reflection question for after this lesson: do you prefer the substitution or elimination method for solving a system of 2 linear equations? Briefly explain the reason behind your preference. So we're going to learn both methods. These should be things you've seen before, but after we've gone over both methods, go back and answer this reflection question on which one you prefer. Again, we're just setting up this page, and you'll go back and fill those in later. All right, so this lesson is something that hopefully you've seen in a beginning algebra course. This is beginning and intermediate algebra, section 7.4 and 7.5. It's also briefly reviewed in your college algebra book, section 5.1. And it's on solving systems algebraically. This will be page 18 of your notes. So I'm just going to kind of show you what I've already written down and explain it as I go. Again, you can pause at any time and go back to write it all down. So the first thing to know is that in addition to graphing a system of 2 linear equations to find a solution, you can also find the solution algebraically using one of 2 methods. So we're going to go over both methods one at a time. The first method is called substitution. We will solve for each variable one at a time. So we're going to have an x and a y in both equations. We're going to solve for x, and we'll go back and solve for y. For substitution, you replace or substitute one variable for an equivalent expression, thus creating one equation with one variable to solve for. And I'll go through those steps here in just a second. But we're going to be substituting an equivalent expression and then solving. So the next thing I would recommend is to separate your page just about in half. The steps are going to be on one side, and we'll go through an example on the other. So we'll go through each step and work the example along the way. That way you can understand each step as we go along. Again, this should ring a bell, should be something you've seen before. The first step is to isolate one of the variables in one of the equations. And so in this example, we have 3x plus 5y equals 26. That's in standard form. And we have y equals 2x. So this y equals is isolated. We call that isolated. Isolate one of the variables in one of the equations, which is already done for us. The next thing we're going to do is make the substitution or the replacement to combine the equations. And so this color coding can be helpful here. We're going to take what y is equal to, the 2x, or whatever else is there. Y is equal to 2x. We're going to take that 2x and replace the y from the first equation. So everything else stays the same. We're going to have 3x plus 5. Instead of y, we're going to put 2x in its place, and then equals 26. So that's called making the substitution. What that does is combine the 2 equations. We're putting this equivalent expression in the replacement of y and creating a single equation with a single variable to solve. So then you just solve for that variable. This part is just your basic solving skills. So 3x plus 10x equals 26. That's 13x equals 26. Divide by 13, and you should get x equals 2. So that might be x equals some number, or it might be y equals some number. It doesn't matter. You just solve for whichever one you have. That's one of your answers. From there, we're only halfway done. We have one answer, but we need the other one. So you plug in whatever you get into one of the original equations and solve for the other variable. So it doesn't matter which one you plug into, it'll work for both. Whichever one looks easier to you. I personally think the second equation looks easier to me. So y equals 2 times whatever we got for x. I'm going to plug in that 2 here. And 2 times 2 is 4. So y equals 4. And your final step is to state the solution as an ordered pair. And so you're going to put your x variable first, and then your y variable. And it doesn't matter which one you solve for first, it always goes x, comma, y, whatever numbers you get. And if you were to plug in those ordered pairs into both equations, it will make both equations true. This is the point where these two lines cross. So instead of graphing, we've solved it algebraically. So again, that should seem familiar. You should have seen that in a course before this one, but we're just going to go over some examples just to refresh our memory on using substitution to solve a system. At any time, if you want to try one of these on your own, you can pause the video, try it on your own, and then play the video back to make sure you got it correct. So let's look at example 2. We have 2x plus 5y equals 7, and x equals -1 minus y. So I'm going to use some scratch paper here so that I have a little bit more space. We have 2x plus 5y equals 7, and x equals -1 minus y. So the first step is to isolate one of the variables. You'll notice here that x is already isolated by itself. It equals -1 minus y. Now we're going to make the substitution. We're going to take the x from the first equation and replace it with -1 minus y. So we're going to have 2. Instead of x, we're going to replace it with -1 minus y. And then plus 5y equals 7. So we're making that substitution. Now we have one equation with one variable to solve for. So from here, we're going to distribute the 2. That's going to be -2 minus 2y plus 5y equals 7. So we distribute and then solve. So it comes back to our solving skills. -2 plus 3y equals 7. I'm going to move that 2 to the other side. 3y equals 9. Divide both sides by 3. And y equals +3. Now normally, when we're solving, we're done. But in these problems, you're only half done. Now you have to take that answer and plug it back into either one of the equations. It doesn't matter which one. I personally do not like dealing with negatives, so I'm going to plug it back into the top. 2x plus 5 times 3 equals 7. Again, that's because I don't want to deal with the -1 minus y. But either way will give you the same answer. So 2x plus 15 equals 7. 2x, you subtract 15, equals -8. Divide both sides by 2. And x equals -4. And we're going to state it as an ordered pair, -4, 3. So again, make sure one of the variables is isolated, make the substitution, solve for the variable. Once you get one answer, your choice, top or bottom equation, plug in that answer, solve for the other variable, state your answer as an ordered pair, x first, and then y. Alright, so I've got a couple more here. Again, you can pause the video at any time and try these on your own. Here's example 3. We've got 2x equals 4 minus y, and 5x plus 3y equals 10. This is a good one to practice because the variables are not isolated for us. So we have to do the isolating ourselves. If you'd like to try this, you can pause the video or you can follow along. We've got 2x equals 4 minus y. Now I'm going to isolate the y. I'm going to move the 4 to the other side. That's 2x minus 4 equals negative y. Then I'm going to divide everybody by negative 1, or multiply by negative 1, to get y equals negative 2x plus 4. So I'm just rearranging that first equation so that y is isolated. Now that I have y equals 2x plus 4, I'm going to use that to substitute in to my second equation. So I'm going to take the y out of the second equation and put in what it's equivalent to, negative 2x plus 4. So for the second equation, that would be 5x plus 3, and then I'm going to replace y with negative 2x plus 4. Parentheses are extremely important on these so that you don't miss any signs or distributing, equals 10. From there, I'm going to solve for x. So distribute that 3. 5x minus 6x plus 12 equals 10. It's going to be negative 1x plus 12 equals 10. Move the 12. Negative x equals negative 2. Divide by negative 1. X equals positive 2. So there's one answer. Now I need to plug that in to one of the original equations. You can go back to the originals or you can use the already isolated one. It should give you the same answer. So let's see. I'm going to plug into 5. I'm going to replace x with 2 plus 3y equals 10. So that's 10 plus 3y equals 10. And then from there, move the 10. That makes 3y equals 0, and that's okay to get 0. Then we divide both sides by 3, and y equals 0. So again, as long as you don't lose your variable, it's okay if it equals 0. It's when you lose your variable that it becomes a problem. So the solution set should be 2, 0. That's the ordered pair that makes these equations true at the same time. Alright, let's try another one here. Let's try x equals 5 minus 2y and 2x plus 4y equals 6. I would recommend pausing the video. Try this one on your own. It does work out a little strange, and so it's a good one to practice. Alright, so we already have the x variable isolated. It equals 5 minus 2y. I'm going to replace the x in the second equation with that expression. So 2 times and then 5 minus 2y plus 4y equals 6. Then I'm going to distribute that 2. So 10 minus 4y plus 4y equals 6. Here you'll notice we have negative 4y and positive 4y. So those zero out and you end up with 10 equals 6, which is not true. And just like when we were solving at the very beginning of the course, if the variables disappear and you get down to something that is not true, there is no solution. What that means is that these lines are parallel. Remember, parallel lines never cross, so they have no solution. So if you're solving and the variable disappears, double check your work, but if you're sure the variable is going to disappear and you get down to something that does not make sense, if it's not true, it's automatically no solution, which means you have parallel lines. Alright, let's look at one more for substitution method. This is example 5. This one also works out a little strange. Let me make sure the projector's lined up here. Give myself some more space. Alright, example 5 we have 3x minus y equals 4. Now what I would recommend on example 5 is isolating the y variable. So I'm going to move that 3x to the other side. That gives me negative y equals negative 3x plus 4. And then either multiply or divide everything by negative 1. So y equals positive 3x minus 4. Now we can do the substitution. So I have 3x minus 4. I'm going to replace the y in the second equation with that expression. So it gives me negative 9x plus 3 times 3x minus 4 equals negative 12. So again, replacing the y with what it's equivalent to once I solve for y. From here, I've combined the equations. I'm just going to solve for x. Distribute the 3, negative 9x plus 9x minus 12 equals negative 12. Notice you have negative 9x and positive 9x, so they're going to zero out. So you have negative 12 equals negative 12, which is always true. In this situation, you have not all real numbers, infinite solutions, which means this is the same line twice. It's not all real numbers, because that just means you can plug in anything. That's not true. It's that anything that works for the first equation will automatically work for the second equation. So this is when you have, again, infinite solutions because you have the same line twice. So any xy coordinate pair that works here will automatically work there. So most of the time you're going to get an xy pair that's a solution. Every now and then you'll get no solution, and every now and then you'll get all real numbers. So what I'd like to do now is go back in our notes to page, wherever that half sheet was that we never finished filling out. It's a little bit earlier, let's see. It's on the back of page 14. So if you find page 14, we had the 3 graphs. On the back of page 14, or the next page, should be your systems of linear equations chart. And we never filled in those 3 at the bottom, so let's do that now. So when you have intersecting lines, you have one unique solution. Algebraically, that means you get x equals something and y equals something. So you get real numbers. Positive, negative, they could be fractions, but we get some sort of real numbers. When you have parallel lines, that's when you get something that doesn't make sense. Like if you get 5 equals 7, that's when you have no solution, and it does not make sense. Does not make, ran out of room there, sense. The variables disappear and you get something that doesn't make sense. If you get down to something that does make sense, like 10 equals 10, something that's always true, that's when you have infinite solutions. So when the variable disappears and you get down to something that does not make sense, it's no solution. That means you have parallel lines. If you get down to something that's always true and the variables disappear, you have the same line twice, and that's infinite solutions. So just when I finish filling that in, I'm going to pause the video here. Each video is about 20 minutes, and then it will cut me off, so I don't want to get cut off. So I'm going to stop the video here, and we'll continue the notes on elimination in the next part.